Hey there, lovely people. My name is Samira Said. I'm currently pursuing my BE from Sri Venkateswara College of Engineering. I'm in second semester, class Chevrolet. My USN is 1BE 23CS150. The course title is Introduction to Civil Engineering and the course code is BESCK204A. Today's topic is the landfill selection and urban flood control criteria and strategies. Contents: need for landfill selection, criteria for landfill selection, proximity and population centers, geology and hydrology, soil conditions and environmental impact, criteria for urban flood control, topography, drainage patterns and floodplain mapping, stormwater management, infrastructure resilience. Need for landfill selection. The selection of an appropriate landfill site is a critical aspect for effective waste management. Landfills serve as the final repository for municipal solid waste that cannot be recycled or repurposed, and their location and design can have significant environmental and public health implications. When selecting a landfill site, factors such as proximity to residential areas, groundwater tables, soil permeability, and potential impacts on local ecosystems must be carefully evaluated. Rigorous site assessments and planning are essential to ensure that landfills are situated in areas that minimize the risk of contamination and disruption to surrounding communities. Responsible landfill selection is a key component of sustainable waste management strategies that prioritize environmental protection and public well-being. Criteria for landfill selection: proximity and population centers. One of the primary concerns regarding the proximity of landfills to population centers is the potential for environmental, population, and public health risks. Landfills can generate various pollutants such as leachate, methane, and particulate matter, which can contaminate the air, soil, and even ground matter if not properly managed. And even groundwater if not properly managed. This can pose risks to the health and well-being of nearby residents, particularly those who rely on local water sources or are exposed to airborne pollutants. Additionally, the proximity of landfills to population centers can lead to increased traffic, noise, and aesthetic impacts, which can negatively affect the quality of life for local residents. In conclusion, the proximity of landfills to population centers is a critical factor in the site selection process. Balancing the operational requirements of the facility with the potential environmental and social impact on nearby communities is essential for ensuring the sustainable and responsible management of waste disposal. Geology. Geology plays a crucial role in landfill site selection and design. The underlying geology of a potential landfill site must be thoroughly evaluated to ensure the long-term stability and containment of waste materials. Hydrology. Hydrology is also a critical consideration in landfill site selection. The flow and quality of surface water and groundwater in the area must be thoroughly assessed. Groundwater depth, surface water bodies, drainage patterns, aquifer protection are some of the factors that need to be looked into. Groundwater depth. The water table should be sufficiently deep to avoid contact with waste materials and leachate. A minimum separation distance is typically required. Surface water bodies. Landfills should be located away from rivers, lakes, waterlands, and other surface water to prevent contamination. Drainage patterns. Site topography and drainage must be designed to divert clean surface water away from the landfill and manage stormwater runoff. Aquifer protection. Underlying aquifers used for drinking water or other purposes must be protected from the leachate migration. Comprehensive geological and hydrological studies are essential to identify an appropriate landfill location that minimize the environmental impact and risks to human health. Soil conditions. The characteristics of the soil at the proposed landfill site play a crucial role in determining its suitability. Factors such as soil permeability, porosity, and compaction capacity should be thoroughly examined. Highly permeable soils, such as sandy or gravelly soils, can allow the latte to easily penetrate and contaminate groundwater resources. Conversely, soils with low permeability, like clays, can provide a natural barrier to prevent the migration of contaminants. Environmental impact. The selection of a landfill site must also consider the potential environmental impact on the surrounding ecosystem. Factors such as proximity to sensitive habitats, wetlands, and water bodies should be carefully evaluated. Landfills located in close proximity to these sensitive areas can pose a significant risk of contamination and disruption to the local environment. Regulatory compliance is another crucial factor in landfill site selection. The proposed site must comply with all applicable environmental regulations, including those related to water quality, air pollution, and land use. Failure to meet these regulatory requirements can lead to costly remediation efforts and legal consequences. These are some of the criteria for landfill selection, among many others. Need for flood control. Flood control is a crucial aspect of urban and regional planning aimed at mitigating the devastating effects of floods and protecting communities from the risks associated with rising water levels. Effective flood control measures involve a multifaceted approach combining infrastructure development, policy implementation, and common and community engagement. Overall, flood control is a multifaceted challenge that requires a comprehensive and collaborative approach involving governments, urban planners, engineers, and community members. By implementing a range of effective measures, communities can enhance the resilience and minimize the devastating impact of floods. Now let's look into the criteria for flood control. Infrastructure resilience. Flood control is a crucial aspect of urban and regional planning aimed at mitigating the devastating effects of floods and protecting communities from the risks associated with rising water levels. Effective flood control measures involve a multifaceted approach combining infrastructure development, policy implementation, and community engagement. Topography. Topography is another important criteria of the flood control measures. Topography, the study of the physical features of a land surface, is a fundamental consideration in flood control strategies. The contours, elevation, and slopes of a landscape significantly influence the movement and accumulation of water during flood events. In low-lying areas, topographic features such as natural depression, basins, and floodplains can act as temporary storage spaces for excess water, mitigating the impact of floods on surrounding communities. The integration of topographic data into flood modeling and mapping is crucial for identifying high-risk areas, designing effective flood control infrastructures, and implementing appropriate land use planning strategies. Storm The stormwater management. Effective stormwater management is a multifaceted approach, again, that combines well designed infrastructure, Nature-based solution